and that gets us to a million seconds. That's about 12 days. You multiply 12 days by 1,000, and that gets you to a billion seconds, which is about 32 years. And I think maybe there are some people in this session tonight who are less than a billion seconds old, whereas as I am approaching 2 billion seconds old somehow. And then we multiply that 32 years, that billion seconds, times 1,000 again to get us to a trillion seconds. And that's 32,000 years, which takes us back to a time before what we recognize as the establishment of civilization and agriculture. So a trillion is a really, really big number, and you should understand that in the context of what you're talking about when you're throwing around billions and trillions. You should very much recognize that one is 1,000 times larger than the other. We Homo sapiens have been around for less than 10 trillion seconds. As I said, we've been recognized as a distinct, or we emerged as a distinct species about 300,000 years ago, and 10 trillion seconds would be 320,000 years ago. And there's some resources for going further. And the idea for this activity, or I shouldn't say the idea for this activity comes from the book Innumeracy, which I think holds up pretty well, even though it was written in 1988 by John Allen Paulos, and there's links in the agenda for that. There is also a Google Doc related to this to step you through this, which will again end up fairly soon as an activity in our resource pages on the Center for Climate Change Education. And I'm going to flip back to the agenda and say a few words. Only 5 minutes behind. That's not horrible. And I will do these. This is more or less a quick look at some related materials that we will not dig into in any depth. So connecting to social studies and ELA, we will take a very quick peek at when we change energy, we change history, and I'm just going to jump ahead to slide 15 and look from there, and I am on top of myself, so I can't see what slide number I'm on. There we go, a couple more to go. And so just an excerpt of a moment from this presentation on the history of energy, which is pretty short. Back in the 1600s or around 1600s, the Netherlands became a world power through energy dominance, and that was both thermal and kinetic energy. The European forests had largely been cleared by 1600, and the Dutch built some really good windmills, which changed their use of energy that allowed them to cut really long boards and therefore make really large ships. And we'll just
per hour.
Jump
with the rope. What they do is they twist that broomstick handle there to hold down the log.
Shut that up. And that allowed them to cut really, really long boards, which allowed them to make really big ships. And that was part of what allowed them to become a world power. And also, at about the same time, why is this not advancing? Come on, there you go. They figured out how to take peat out of the ground and burn that for energy. And their power faded because the same plot line that's played out over and over again throughout human history, somebody figured out how to exploit an energy source and essentially mastered it. And then they used up the easily accessible supplies, and it became more and more expensive and more environmentally damaging to access those resources. And it became an impractical resource. And then somebody figured out the next energy source, and that happened with Dutch peat, American forests, with coal, and so on, for extracted resources. And then you can continue on from there and look at the Industrial Revolution. and so forth. But we don't have time to do that. But you can take a look at that on your own time. And where did my agenda go? And um, I will just point to stay on time, that blog that I posted in the chat earlier has links to some other things. I will click on the um, stuff related to the New York State Seal of Civic Readiness, which is an optional thing that students can do, where it includes the expectation of doing a civics project where students do something that matters to their community. And there's a rubric for it, which I think gives a pretty good overview of that particular expectation. But you can again click through to those resources from the blog and the links within the agenda. And I am going to stop there and pass it off to Ingrid right on time.
Actually, I think you're early.
A minute early.
Yeah, thank you.
So maybe one question if somebody's got a question on any of that stuff. I know it was very fast, but again, it's to show you what's there, and then you can take a closer look later. Take it away, Ingrid.
All right. So I'm going to do an activity together with you, an activity we've developed for kids. It is on our website, Earth at Home. I've put a link in the chat. So Earth at Home is a website that has the vast majority of our scientific and educational content at PRI. It has different sections, and the link I put in is for the climate section of Earth at Home. I'm going to share my screen just briefly and show you. Okay, so here's the climate section, and you see some top navigation here. I think Rob is going to go over this in more detail, but I'll just lead you to the activity. If you go to this section called Teach Climate Change and scroll down, we have a bunch of teaching activities, lesson plans essentially, related to climate science, climate solutions, communication. And the one that we're going to do today is called Vision for a Better Climate Future. Okay, so I think I'm actually going to stop sharing. I'll just kind of talk you through it at this point. We're going to do a highly abbreviated version of this. So this is an activity that you would do in a single class period, but we're going to do an abbreviated version in about 15, 20 minutes. So what it is that, well, maybe I'll just start it with you. So I'd like you all to think about where you live, the community you live in. And maybe you could put in the chat some things that you think makes your community a good place to live. What do you like about your community? Okay, so I see some things already about the people, population density. I see something about the landscape, prairies, rural character, diversity, safety. So maybe that's something about the culture, social setting, geography. Great. Lots of great thoughts. And I think no matter where you live, you can always come up with something good, something you like about your community. And so this would be a discussion I would have with kids. And I should say, by the way, this activity I've run with elementary school age kids, but I think it could be done with any age, including we're doing it now as adults. All right. Okay, lots of more answers coming in. Excellent. So parks, history, open space, water. So now, you know, maybe you'd have a discussion with the kids about the answers they give. And then you could suggest to them that even though we have a lot of great things in our communities, we do have some problems too. And one of the problems that everyone around the world is facing is our climate is changing. And that's bringing some challenges for our communities. But maybe there's some things that we can do to face those challenges and make our communities even better with climate change happening, or maybe to um, stop or slow down climate change. So here, it depends on your situation. At this point, you might want to give the kids some background about climate change, or maybe this is an activity that's best done if you've already introduced climate change as a concept and talked with them maybe in other lessons about what it is and why it's happening. Um, okay, so that's kind of the context, thinking we live in nice places, but we do have some challenges. Climate change is one of them. Now, I would ask you all to use your imagination. Imagine that it's, let's say, 20 years into the future, and in your community, you've made some changes to make it better, particularly to try to combat climate change or do things to improve the environment for people, for other living things. So I'll ask you, what is your vision? What is your picture of your community 20 years from now when you've done these good things? And what is it like to live there? And you might want to give the students some examples of what things could be. And there are some in the online lesson plan. I'll just read you a few of them. Um, so I would say now, 20 years in the future, we use more renewable energy instead of fossil fuels. Now we can bike and walk more easily and safely to get around because people built paths for these things, paths where people could bike and walk. We have better ways to heat our homes now that don't involve burning gas, oil, or coal. When people built new homes as they needed to, they made sure to cut down as few trees as possible to preserve habitat for wildlife. We figured out ways to waste less food. We started thinking about land more as something to take care of than something to be used. Electric vehicles became a lot more affordable, so most people could afford one. We planted trees in our neighborhoods to soak up rainwater when there were heavy storms and to give us shade to keep cool, and so on. There are more examples listed on the website, and you could come up with examples. You could even tell a story, and there's a story that I've told about public transportation that's on the website, but I don't think I'll read it to you. I think what I'll do now is give you some time. So why don't you do this for yourselves? Take 5 minutes. Imagine it's 20 years into the future, something got better. And um, at this point too, with the kids, well, usually what I do is have them share out their ideas and then we move to the next part. But I think since we're doing this in abbreviated fashion, we're going to move right on. So think of your idea, imagine your future vision, and then either write it out. So this is where you could do this in a ELA setting, or sketch it, draw it. And I've most often run this as an art activity where I have kids make drawings or I give them materials so they can make three-dimensional artistic representations of their vision. And you can see some examples of that on the website. So go ahead, take 5 minutes. If you have a piece of paper, you can write, you can draw a sketch, and then we'll share out a little bit. There's a question. Go ahead, Sahar.
Hi, good evening, everyone. I'm in the meeting. I get it through my email. I'm introducing myself as I'm a special ed teacher. So we've been working with the students with disability. We got a grant for a hydroponic system. I actually got it from Green Our Planet. It's from different state. We got to work together through climate change and how this is affecting our the whole entire world. It's not only America. Or I'm Egyptian originally. I've been observing in the school system how much waste, as you mentioned it. So I lead my students with a team called Zero Waste, and we start to collect the food, the leftover food, to send it to our compost, and we teach the students how to use this to, to the land, and also using hydroponic that shows them that we can have our small business inside a small space. We don't need to waste water. We don't need a big space of land. It's been very effective to use it with the students with disability. I start to be enrolled in an administration program because I want to see from now 10 years and, in the future, how the students with disability can be big part of climate change, and didn't have to be in college, but they can use the skills that we've been working on from now and this future.
Mhm. That's great. Yeah, I love tackling waste because it's something that kids of all different ages and abilities can be part of. So that's wonderful. Well, I'm not sure it's been quite 5 minutes, but and I don't think we'll have time for everyone to share out, but does anyone want to share your vision of a better climate future? What you drew or what you wrote? Alex, okay, you have a bicycle. Tell us about your bicycle.
I'm a huge cycling fan, and I spend a lot of time in European cities where cycling is what people do every minute of every day. And when I get on my bicycle here at home, it's terrifying. So I would love to see a city like Ithaca that is 100% cyclable, 100% walkable.
Thank you. Anybody else? Don, yes, what did you imagine?
Well, I'll just jump in and say another maybe helpful strategy for thinking about this is pointing out how much the energy system changed, for example, between 1925 and 1945, and how in 1925 the leading transportation fuel was still coal for trains and ships, and by 1945 that had changed to liquid transportation fuels and gasoline and diesel fuel, and that made a tremendous difference in the way the world worked. And I think we can expect as big a change between 2025 and 2045, but hopefully with improvements to the environment coming along with those changes rather than kind of messing it up. While it did improve, it's very much worth noting, it improved the quality of life in a lot of ways, but it also is really complex. So,
Mhm.
and another interesting example is the Pan American Exhibition in Buffalo in 1901 was the first time a lot of people had ever seen electric light. And just imagine coming in on a train into Buffalo and seeing the exhibition ground lit up with thousands and thousands and thousands of light bulbs after you've never seen one in your life. And, thinking about those remarkable changes in the past, I think can help us think about remarkable changes in the future.
Mhm. Thank you for mentioning those ideas. And it occurs to me also that I often view this activity as an art activity or as an ELA activity, but I think it could also fit well in a social studies class, because an important component of the discussion is when you're talking about what the kids are imagining for the future, then to think about, well, how did we get there? How did we go from today to that 20 years? And a lot of that is a social component. Like Alex, your idea, the community have to decide to invest in infrastructure to make it safer to bike, right? And all the complications involved in that. So, all right, anybody else want to share their vision for a better climate future? Susan?
Well, since we're going to have climate education in the schools, starting within a few years, in 20 years, my vision is that the kids are leading our solutions because they are so creative and so amazing. And they'll be working with, interdisciplinarily within the community to really push everything forward in a more positive direction once they have this basic understanding and are no longer operating in fear of what the future holds. Thank you.
Thank you.
Maybe we have time for one more person or one or two to share out, and then I want to show you some examples of some things that kids created. All right, well, maybe we'll move on. I'm going to share my screen. Okay, and I'll start with some photos. So this was a boy doing this activity. In this case, we focused the activity on adaptation and resilience. So when I asked the kids to imagine a better climate future, we gave them information about what climate change is doing in terms of extreme weather. And here in upstate New York, the biggest issues are flooding, much more severe flooding, heavy rains, and extreme heat. And so I asked them to imagine, solutions in the future. This boy came up with the idea of building a house. So this overturned cup is a house. Maybe you can think of it like a tall building. And he put an umbrella on the top. That's what this is. And then he started building some steps. He has one toothpick taped there. Let me show. Oh, here's another. So these are steps. It's like a ladder to get up to the roof. And when I asked him to describe it to me, he said, when it's too hot for people to stay inside, they can climb up the ladder and go up to the roof and sit under the umbrella for shade. Which I loved. It was just this simple solution. And so that was one idea. And then another one, and here I'm going to turn on some audio, make sure that you can hear it. Okay. So you can see the picture. This is by a boy named Graham. There's a picture of a car. It says last $50 hover cars, and I'll play you a recording of what he said about it.
The $50 hover cars will make it so it will be easier to go somewhere, and it doesn't take away a lot of energy from the world. And it's not usually like hybrids, and I made it $50 because they're usually like $2,000 and nobody even has that. So I decided to make it some $50 cars so they wouldn't have to work so hard if they wanted one.
All right, so that was Graham's wonderful vision. And in that case, in the discussion we had before they started doing the activity, here we were talking more about climate change mitigation solutions, and the idea of equity, accessibility, affordability came up in the discussions. I don't remember if he was the one who brought it up or if the adults or other kids brought it up, but clearly it was on his mind, thinking about it's a climate solution, but it's got to be affordable for everyone. So there either all different ways you can take this, and depending on what you want to focus on in your classroom. All right, I think I will finish there, and I don't know if anyone has any questions or anything they want to say about this activity. Again, if you were doing it in your classroom, there'd be a lot more talking with each other about what you're doing.
Oops.
All right, well, we'll have more time for general discussion at the end, so I'm going to pass it on to, let's see on the agenda who is next. It is Alex.
All right. Thank you, Ingrid. That was so much fun. So I'm going to follow on Ingrid's activity with another activity, and it's actually going to circle back around to Don's idea that understanding really big numbers is important. And the question that I'm going to ask you, let me get my prop. Here's a 1 liter Nalgene bottle. How many carbon dioxide molecules are in this 1 liter bottle? And this is an activity that was prompted actually by doing a face-to-face climate workshop in which we had a climate change skeptic or denier, let's call him. And he challenged us. You know, we were talking about infrared energy leaving the surface of the Earth, and the infrared energy is interacting with the molecules in the atmosphere, making them, the greenhouse gas molecules, making them vibrate, making the climate warm. And he said, look, you know, the concentration of CO2 in the atmosphere is only 400 parts per million. What are the chances that outgoing energy is even going to hit one of those? You know, there's so few. Well, let's figure that out. Let's try to answer that question. And so to do that, I am, of course, going to share my screen. And while I'm sharing my screen, I'm going to give you about 10 seconds to find a pencil and a piece of paper because this is interactive. Okay. Boom, boom, boom. Okay. So here's the question. You got your pencil? You ready? So what we're going to do is we're going to do a quick estimate. All right. We're going to do a back of the envelope calculation. And so this is an activity that's going to cross the boundaries between some math and some chemistry. And I'm actually going to do this on the back of an envelope. And I hope that you all have got your pen and you're going to calculate along with me as we do this. Okay. So how many carbon dioxide molecules are in 1 liter of air? So if we're counting molecules, we're going to want to start with Avogadro's number, with thinking about a mole, which is the appropriate quantity here. And because this is a back of the envelope calculation, I am going to estimate. Instead of using 6.022, we're just going to call this 6 times 10 to the 23rd molecules in a mole. And then next, I need to know at standard temperature and pressure, what's the volume of a mole of air? And it's 22.4 liters, and we're just going to round that off to be 20, or 2 times 10 to the 1 liters. Okay, and now I've written this. Are you writing this with me? All right, we've written it as a quotient because we want to know the number of molecules per liter of air. And the reason to do this in scientific notation is this makes it so easy to divide and so easy to do it quickly in my head or on the back of an envelope. So if we're going to divide 6 times 10 to the 23rd by 2 times 10 to the 1, you know how to do this, right? We're going to divide 6 by 2. That's going to be 3. And then when we divide 10 to the 23rd by 10 to the 1, we're subtracting the exponents. So it's 10 to the 22. And this is the number of molecules per liter of air. So that's how many molecules are in here. But we only want the carbon dioxide molecules, which exist in a concentration of, I forgot to check today, but let's say about 415 parts per million. So that'll be the next thing we're going to need to know. And again, I'm going to round this off. We're going to call it 400 parts per million. So 400 parts per million is 400 times 10 to the minus 6. And if we reduce that, that's 4 times 10 to the minus 4. And now I need to multiply that by my previous result. So we're going to multiply 4 times 3, which is 12. And then 10 to the 22 times 10 to the minus 4, we add those. So that's going to be 10 to the 18th. So that's 12 times 10 to the 18th molecules of carbon dioxide are in my 1 liter bottle. You can say that instead of 10 to the 18th, a billion is 10 to the 9th. So you can say that's 12 billion molecules of CO2. So that's a lot. And in fact, I think my climate deniers question, what are the chances that outgoing infrared energy is even going to hit one of these? I think the question ought to be flipped on its head. How could it possibly miss? Okay, so here's an example of a really large number. Here's a very simple math problem that we did using something from chemistry to get us started there. And if you are not mathematical, if you're a more visual learner, you can look at these concentrations, these numbers like 400 parts per million. Visually, here I've dropped one little dropper of black ink into a jar. And this is what the concentration of ink looks like if you've got 0 parts per million, the clear jar, 200 parts per million in the middle, and 400 parts per million on the right-hand side. So that ought to make you think, eek, I'm drinking that stuff. I'm breathing that stuff. 400 parts per million is actually a lot. It's a really high concentration. So we've set up a number of video lessons or activities or experiments that you can access with your students. You can either look at them yourself or you can get the whole class involved. Some of them are just sort of demonstrations. Some of them are actual activities that the students can go through. What I just showed you here is a pinwheel that's been set up to lift a little bucket full of pennies. And so if you've got high school students who know some physics or some math, you can actually calculate the power of that pinwheel to lift that. If you've got younger kids for whom that's not accessible, you can just build the pinwheel and say, look, it does work. All right, we can get useful work out of things like pinwheels. And so on PRI's YouTube channel, we have tons and tons of videos that you can take a look at. And these are all linked on the agenda. And stop sharing screen. Actually, Ingrid already showed you our climate resources on the Earth at Home webpage. All of that stuff is linked there. Activities written up with lesson plans, as Ingrid showed you. A link to all of the video resources that we've created are there, these video lessons. In the agenda for this meeting, underneath the actual agenda part, I listed some of our videos sort of divvied up by discipline. So if you're interested in doing something based on physics, if you're interested in chemistry, earth science, biology, we even have some sort of history of science or day in the life of science videos. Those are all there, and I hope that you and your students can take advantage of those. And because I was only supposed to speak for 10 minutes, that is it. And if anyone has any questions, I would be happy to answer them.
I will note I went too fast, which will just give us more time for questions.
Don, I am speechless that you ended soon. Does anyone have any questions or comments? All right, then whoever follows me.
Believe that would be me.
That's you, Rob.
Okay. So in principle, I'm bad in cleanup, but we'll have some time for discussion or questions or suggestions or ideas after I go. So my role now, after making some suggestions about some activities that you can do in the classroom, is to actually go through in kind of a systematic way some of the resources that we have available. And there are links to all of the things that I'm going to talk about somewhere on the agenda. And some of the things that I'm going to mention are things that you have already heard of. So let me share my screen. Okay. And I want to start by explaining a little bit more about who we are. So we are the four of us, Alex, Ingrid, Don, and I, work for a natural history museum that is called the Paleontological Research Institution. And it's a natural thing that people who do research in paleontology would be thinking about climate and geologic history of climate and energy resources and so on. But a lot of the outreach that we do is centered broadly in earth and environmental sciences. And right now, as you would expect, we are focused especially within climate and energy. We've been doing that for a long time, and we recently decided to kind of package that in a way that we thought would be easier for people to understand. And so you'll see us describe ourselves as coming from the Center for Climate Change Education at PRI. And so we are not a standalone organization, but we are part of this Natural History Museum. And that was formally founded a little bit over a year ago, but in fact, I think all four of us have actually been thinking and doing things in climate change since the 1980s, and together for well over a decade. Of course, you know from this evening's workshop that we do educator professional development. But I should mention in this context that we also do professional development kind of by request, for schools and school districts and other organizations. So if you happen to have a need for that sort of thing, or you know somebody who does, we would be happy to tailor programs for specific needs. Because we can only reach so many people in workshops, we produce other resources like the ones that you've heard about. And so we do things like publish books, for example. And one of the books on here that you'll see that I'll describe in a couple of minutes is The Teacher-Friendly Guide to Climate Change, which came out in 2017 and won a big award in 2019. This book, although there are, of course, many books about climate change and teaching climate change, and some of which are excellent, ours is a little different in that it does have both the science and chapters on how to think about teaching, and then things about just understanding our audiences, things like cognitive biases. So all of that is wrapped together in this one book. We have many copies available, so if that's of interest to you, let us know. If you're ever in Ithaca and you haven't visited the Museum of the Earth, we hope that you'll do that. That is our exhibits and education facility. We have a pretty major climate change exhibit there, but you can also visit that online, and I'll get to that later. And there's also there are a couple of versions of our exhibit. The one at the Museum of the Earth is focused on kind of climate and energy at a national scale, and in some cases even global. But we also try to help people understand their local and regional climate change. And so we have an online exhibit about climate change in Central New York. We work with lots of different organizations already. Emily talked to you right at the beginning about the Climate and Resilience Education Task Force. But there are lots of others that we collaborate with, and this is really critical right now as we try to band together to be a force in climate change education broadly. So as you've heard from Don and Ingrid and Alex, having activities for kids to do and think about climate change is critical. Changes that they can make And among the kinds of things that we do is involve kids in making observations of nature that is part of doing something. If you're tracking climate change by collecting data, weather data, or you're tracking climate change by observing how plants are faring from year to year to year, for example, those are ways of participating in citizen science, or perhaps even kind of projects at a classroom or a school level. So we do these bio blitzes. These are quarterly in the Eastern Finger Lakes, where we invite people to contribute data over the course of 4 days, seasonally, so 4 times a year, to document the flora and fauna of the region. And all of these observations are done using an app called iNaturalist. But of course, you can run iNaturalist BioBlitzes yourself. Even if you're not in the Eastern Finger Lakes, you don't have to be a part of ours specifically. You can do them in your own schoolyard or organize them for your area. It's a great way to track what's happening to organisms. Of course, there are many, it's not just climate change, there are other areas of environmental change, but getting kids looking and making observations that actually are part of the data set is I think really meaningful and motivating to students. And Ingrid runs a program where she collects data on tree budding through time, and that is another way. The field is called phenology. It's another way to track how changes in weather from year to year are impacting our local plants, and it's observations that anybody can make with a little bit of training, and a way to contribute to a big national database. So Earth at Home, as I think Ingrid mentioned, is this website that contains a lot of our content. And Ingrid showed you a specific piece of this. You'll notice up at the top, so this is Earth at Home written out like with ATHOME, .org. There are 4 sections to this: Earth Science, Climate, Biodiversity, and Evolution. And of course, the climate one is where most of our content goes. And if you scroll down, there's a little bit of information about the Center for Climate Change Education. Who are we? What do we do? There's a section on the Teacher-Friendly Guide to Climate Change, and here you can find free updated chapters from this book. Anybody can use them. We've actually removed the language about teaching so that it feels like a resource that anybody could use, including your own students. And then Teach Climate Change is the section that Ingrid mentioned that have lots of different activities, and you can sort them by grade level and so on. Quick answers are FAQs. They're among the most popular parts of our site. And you might also find them useful, but they are the way a lot of people find us in Google searches. And then videos. So Alex talked about a series of videos, which are really amazing. Ingrid has also made a series. I'll mention some others in a moment. Then there are exhibits, and then there's other resources, which might sound like it's just a miscellaneous small stuff, but there's really good stuff in here that might be helpful in your teaching, because some of it is connected to a lot of data for New York State and other parts of the country. It's a great way to find data resources. So I'll draw your attention first to the New York Climate Change Science Clearinghouse. And this has just dozens and dozens of data products and related resources on everything from climate. I'll just keep scrolling. We'll try not to make you dizzy. Flooding, sea level rise, energy, public health, and so on. It's an amazing resource. Other things to know about, if you happen to be in Central New York, there is a page devoted specifically to some data sets that Ingrid has put together on climate change in our region. Here's a thing about our BioBlitzes, more about the videos, and so on. So just know that this is here. I also this slide says what I just mentioned, and I'm gonna skip ahead to these YouTube videos. So Alex showed, I think it was maybe a screenshot or maybe a YouTube channel. So we have our own YouTube channel. It is easy to find if you go to priweb.org/YouTube, or you can just search our name on YouTube, of course. You might be surprised how many videos we have on here. We've been making them for years, especially when COVID hit, but both before and since. And I have clicked the playlists here. And so it might seem like an overwhelming number of videos even to be aware of. But if you click on the playlists link, you'll see a lot of other things. A lot of organization that'll make it easier to find what you want. So here, for example, is the In the Greenhouse Exploring Climate Change video series from Alex. There's a series of videos by a Cornell climate scientist, Professor Toby Alt, called Night at the Museum. These are kind of summarized versions of the lectures that he gives to a course at Cornell, a very popular course. And Science in the Virtual Pub is a series of webinars that Don runs. They're twice a month, second and fourth Thursdays of every month. And we just celebrated the 100th episode. Many of them are talks by scientists or educators about climate change. So they might not, even though they don't necessarily translate directly into something you'll use with your students, they'll definitely expand your boundaries. And half the people who come to these, honestly, are educators. And we have sort of a lot more are pulled together in this one just called Climate Change. I don't know if some of the more recent ones are in there, but you get the idea. There's a lot here. Happy hunting through there. Ingrid has a series called Climate Solutions in No Particular Order. These are very short videos and might be quite good for students because they're just, a minute long, and they kind of summarize a topic in a short, succinct way. All right. We also, on our website, so I'm going to go to priweb.org. So this is kind of the home site of our 4 sites. Notice along this bar here, Paleontological Research Institution, Earth at Home, Museum of the Earth, Cayuga Nature Center. These are all parts of the same family of websites. They link back and forth to each other. And within this are blogs and you'll notice that one of the ones that Don mentioned, and really kind of the idea behind this whole workshop this evening, is this blog, Climate Education is Changing in New York State. But also on here is a blog posted just today. It's called An Experiment with Data Collection. I love this. It is a project by Toby Alt. He's the guy that I said has a series of videos from his class on our YouTube channel. Toby's always filled with fun and creative ways of collecting data. He was recently on the West Coast making a drive from Southern California all the way up into Oregon. And I'm just going to move through here to this photo that shows his rental car with an air quality monitor taped to the top of the roof of the car. And he drove this car from San Diego all the way up to Portland and collected all this data in his air quality with his this air quality monitor. And it's fascinating because you can see the changes in particulate matter and temperature and humidity and so on as he goes through these different belts and in and out of cities. But the important thing in this case isn't specifically the data that he collected, but rather the creativity in saying we can take an instrument that costs a couple $100 and we can learn a lot about our local environment. And so Toby's idea is that every kid should have access to these, and we can have kids on bicycles riding these things across the city. And this was sort of like a, just a demo project of his to show how it could be done. So anyway, we have a lot of our blogs, I think, are very interesting and fun in that way. And finally, if you say, that's an awful lot to keep up with, I'm busy and I can't constantly be checking the PRI website to see what's new and so on. Adan has solved that by creating this Learning Earth newsletter. And this is available on our website, but you can also be on the mailing list. He sends it out 5 times a year, and I guess you know about this workshop as probably as something that is a part of this, that we always have one of these workshops after the newsletter goes out. So you all may be very familiar with this, but it is the best way, I think, to keep up with our newest events and workshops and resources. And with that, I'm going to stop sharing. We have about 15 minutes left, and I'll hand it. Yeah, I'm certainly happy to take questions. I don't know if you'll have any, but I see that Don put Learning Earth newsletter link, the most recent one, into the chat. So I will pass it back to Don. And
Yeah, and I think we'll just open it up for questions for a few
Yep.
minutes before we go to climate haikus to close us out. But questions, comments, anything you want to share, and I will note that we do have some pretty smart folks in the room. So questions, comments, anything folks either want to ask or want to share.
I'll say, if you ever find that you need something, for example, you're looking and you say, I just don't have the time, but I'd really love to have X for my classroom or whatever it might be. Please let us know. We might not have an answer. We might know where there is an answer, or maybe it would give us an idea for something that we could do to be helpful.
So quiet. And
Yes.
maybe we should break into breakout groups for just like 2 minutes to ask folks to come up with a question. 3 minutes. Let's go 3 minutes. And I am no longer the host. Ingrid, can you click the either make me host or click the breakout rooms thing? And
Yep, I will set that up. Let's see.
okay. And your task in the breakout room is to just come up with a question or a comment or something to share. And if we get in there in a minute, we'll come back in 3 minutes from when we send you off.
All right.
So there you go. I guess I will jump up. Welcome back, and let's just hear quickly just a couple of words from each breakout group. And I think there were what, 3 or 4 groups, Ingrid?
Yeah, I think there were 4.
Okay, so was our group 1, Rob?
Oh, I didn't notice.
And I am no longer a host, so I can't see that.
I don't
So
know. Yeah, whatever. Maybe
Yeah.
just people know which group they were in even if they don't have a number.
Chris, can you share from our group?
Yeah, good afternoon, good evening, everybody. So I was just telling our group I work for OCM BOCES, which is outside of Syracuse, and we have a dozen of the air quality eggs that we can loan out to schools and things like that. So, and I have to be honest, like I struggle with. I'm not as creative as other people, apparently, clearly, but struggle with like ways that people could use them. And so, I was just thinking, like, if other people have ideas and things like that, I'd love to chat about what those options might look like and what suggestions people might have. And also know that if you've never met Vic, the guy who owns the company, he's quite helpful with things like that as well. So yeah, that was our conversation.
Do you know if your BOCES is allowed to lend them out to other regions, other BOCES regions?
Yeah, I mean, I would have to check what the details would be, but I would think so. I imagine we could make it work.
Chris,
And-
we'd be happy to. We talk a lot about that, and in fact, I bet you Toby, the guy that wrote that blog, he would be over the moon to talk to you about ideas for how they could be used. So let's connect about that.
I will my email in the chat, and then
Great.
yeah, I mean, I'll
Yeah, and I just a note for Syracuse area folks, I'll actually be doing a thing at Most in Syracuse on Saturday morning if anybody wants to come. It's really targeted for like middle school age kids, but it's open to folks of any age. And for those in the know, I'll be staying with Bryce and Judy Hand on Friday night. How about hearing from another group real quick before we go to climate haikus?
Group 4 talked about changing climate zones, both USDA climate zones marching from north in the past, and then projections for how New York is going to look like Virginia in the future. And then we also talked about the air quality ags and giving kids data sensors.
And to keep us on time for wrapping up on schedule, why don't I hand it back to Ingrid for climate haikus?
All right, thank you. Yeah, this is just one, another example of the intersection of our resources in science and English language arts. So I think Rob showed you on Earth at Home in the climate section, this section called Other Resources. And if you scroll down to the very bottom, there's a tile for climate change haiku. And I'll just show you these. So these actually started as Instagram posts, started in the winter. So you see they're sort of winter themed. So I picked an image, I wrote a little haiku, and then the haiku was associated with some scientific content related to the image. So this one, the haiku is, can we remember winters 50 years ago? Data show the change. And there was a study that came out in 2019 that found that when people think about the weather and what's normal, what they think of as normal is just from about 2 to 8 years ago. We can't really remember, even if you're over 50 years old, it's hard to remember what normal winters were 50 years ago. But fortunately, we have data sets, and in those you can see the change. So that's just one example. There are a few more here. So this is not really a lesson plan, but it's something you could look to for inspiration, maybe working with an English teacher, have kids look up some science, climate change science, and then write a poem about it. Some of these are not really science related. This one was just thinking about the experience of winter, and having fun, cracking the ice or smacking ice with a stick and breaking it. And that's not going to be very common, maybe in 100 years, that people will be able to do that. So that's it. I just want to show it to you. You can check it out on your own and see if your students might want to write some poems.
And with that, I think we can see if there are any last questions, comments before we wrap up for tonight. And thank you all for joining us. And I'm happy to stick around for a few more minutes if anybody wants to stick around for a few more minutes.
Do you have a specific spot on your website when you guys have webinars, etc., that you keep kind of like a running, here's this cool thing?
Yes, we have our events calendar is the place to go for all of our stuff, which is just PRI web.org/events. And these are also, as Rob said, announced in the newsletter. But if you check on the events calendar, you can see all the stuff that's coming up. And I can put in the newsletter link again too. I can get to the right place anyway.
And I'll just say, we've showed you a lot of our resources. We would be very interested in knowing what resources you wish you had. So, I mean, we can talk about now, or if you want to email us in the future, if there are gaps in what we provide or content you wish you had, we would love to know.
Yeah, and generally we do record these webinars, though we forgot to start it at the beginning, so we missed the first few minutes of today's. I don't remember exactly when we started, but and that'll be up on our PRI YouTube channel under the live tab immediately. I mean, it's actually there now. If you go there now, you will find it.
And I love there are some comments in the chat area for suggestions from about from Shannon how to use air quality monitors and so on. Anyway, I'm sure there are tons of ideas that you all have that maybe if we rejoin at a later time, we could share those. So thank you for these. And thank you for staying late on a Tuesday evening near the holidays. All right, thank you all.
Yeah, and I'll just in closing, I'll put a link to CBS this morning had PRI on it this morning, and there's the Instagram link to the story on that, on our fundraising campaign, and how a different Alex than the one here tonight, has a 14-year-old high school student, has helped us out a lot, and the fundraising has gone well in December, and things are looking a little bit more encouraging. So that is good news.
Yeah. All right. Thank you, everybody.
Good night.
Good night.